type of solution. This is solute, this is solvent, and we have example. The first one which we will discuss is termed as gaseous solution. The next one is liquid, and the next one is solid solution. The first one which we have gaseous solution. As I have told you that in case of gaseous solution, the major component, that is the solvent, is in gaseous state. It means in this gaseous solution, in all these three solution, we have the solvent in gaseous state. And the solute, we know the first one gas in gas solution, the next one liquid in gas, and the next one solid in gas. The first one gas, liquid, and the next one solid. Next to that, the same is there. We have the gas, the next one liquid, and the next one solid. This is liquid solution. Then we have the solvent is in liquid state. This is solid solution. Then the solvent we have, or the major component we have in solid state, that is in solid, solid, solid. This is how we have 9 type of solution based on their physical state. The first which we are discussing is the solution of gas in gas. The example of gas in gas is our atmosphere. It means the oxygen in the atmosphere, that is 21%, it is acting as solute, and the nitrogen in the atmosphere, which is 78%, it is acting as solvent. That is an example of gas in gas solution. It means the oxygen in nitrogen in our atmosphere is an example of gas in gas. To the next, we will discuss the liquid in gas. The chloroform vapors dispersed in the gas is an example of liquid in gas. The chloroform vapors, they are in liquid state, and when they are dispersed in gas, then it is a type of liquid in gas solution. Chloroform vapor dispersed in gas is an example of liquid in gas solution. The next one we will discuss the solid in gas. The camphor dispersed in gas. The camphor, which is in solid state, dispersed in gas is an example of solid in gas solution. Camphor dispersed in gas is an example of solid in gas solution. We'll move to the next one, liquid solution, that is gas in liquid. We know the oxygen is dissolved in the liquid, which is important for the aquatic life forms. Therefore, that is an example of gas in liquid. It means oxygen dissolve in water. Oxygen dissolved in water is an example of gas in liquid. So the next one we will discuss liquid in liquid. Liquid in liquid, we have the example that alcohol or ethanol dissolved in water. Ethanol dissolved in water. To the next one, solid in liquid. We have the good example which I have discussed it, that is sugar dissolved in water or the glucose dissolved in water. Glucose dissolved in water. Next to that, we have the solid solution, the gas in solid. We have also studied the hydrogenation reaction in class 10th in which the hydrogen gas is absorbed in nickel, platinum or palladium. So what we have? We have hydrogen gas absorbed in platinum, nickel or palladium. The next one, we have liquid and solid. The amalgam of mercury with sodium. It means when liquid mercury is dissolved in sodium metal, then it forms liquid in solid solution. Amalgam of sodium. Its term is amalgam of sodium is an example of liquid in solid solution. To the next, solid in solid, we have the example that is the copper dissolved in gold is an example of solid in solid. Copper dissolved in gold is an example of solid in solid. Liquid in solid, amalgam of sodium, that is mercury is dissolved in sodium This is, we have the type of solution and which is categorized on the basis of the state of the solute and the solvent. What we have? We have the gaseous solution in which the solvent is gas. We have three types of gaseous solution. The first one is gas in gas, liquid in gas and solid in gas. The example of gas in gas is our atmosphere. Liquid in gas, liquid, it means the chloroform vapors which is in liquid state. When it is dispersed in gas, then that is an example of liquid in gas. The next one, solid in gas, the camphor dispersed in gas. The camphor which is in solid state, when it is dispersed in gas, then it is an example of solid in gas. So the next we have discussed liquid solution, that when the solvent is in liquid state, it is termed as liquid solution. We have three types of liquid solution. The first one, gas in liquid. We know the oxygen is dissolved in water, which is important for aquatic life forms. That is an example of gas in liquid solution. Oxygen dissolved in water. The next one, liquid in liquid. We know ethanol mixed with water. That is an example of liquid in liquid solution. Solid, liquid, solid. When we dissolve glucose or sugar inside the water, then it is an example of solid in liquid. To the next, we have solid solution in which the solvent is solid. We have three examples, three type of solid solution, that is gas in solid. We have the example hydrogen gas which is absorbed in the platinum. The next, liquid in solid, that is liquid, the mercury when it is dissolved in sodium metal which is in solid state. The next one, solid is solid, the copper dissolved in gas. Do confuse it with colloidal solution. Because the difference we have already studied in class 9th, that in case we have three type of solution, that is true solution, suspension solution and colloidal solution. The colloidal solution and the type of colloidal solution with their example we have already studied in class 9th. In this class we are discussing the solution, that is the true solution. It is also stated as solution. We have already studied. Then in case of true solution, suspension solution and the colloidal solution, only the true solution is the homogeneous mixtures which we are discussing here. And we have also discussed that in case of true solution, the size of the dispersed phase particle is less than 10 to the power minus 9 meter, which we should care here. That this solution is different from the colloidal solution which we have studied in class 9th. Next to that, we will discuss the next topic, that is expressing the concentration of the solution. Expressing the concentration of the solution. We know most of the chemical reaction occur in solid state. In solution state. Most of the chemical reaction occur in solution state. Then we have to know their concentration. It means what is the concentration of different substances which are reacting with each other. In order to express the concentration of solute in a solution, we have various ways. We can't say it as it is a concentrated solution, it is a dilute solution. Because if you say a solution to be concentrate, it means it has higher amount of solute. If we say a solution is dilute, then it has lower amount of solute. But by saying concentrate or dilute, we can't differentiate two dilute solution or two concentrate solution. Then in order to differentiate two concentrate or two dilute solution, we have various way of representing their concentration. To the next, this is about the quantitative analysis. Qualitative analysis, what it means, what is the content in the solution? What are the various components in the solution? It is termed as qualitative analysis. And the next one, quantitative analysis, it means what is the content of various component? What is the amount of various component in the solution? It is termed as quantitative analysis. In this chapter, we will discuss the various ways of expressing the concentration of the solution. Let us discuss. Expressing the concentration of the solution. What is the first? First of all, we will know what is qualitative. Qualitative analysis. Qualitative, it means what are the different components in a solution. If we try to know what are the different components in the solution, then it is termed as qualitative analysis. To determine the various component in the solution is termed as qualitative analysis. The next one, quantitative. We will discuss quantitative means what is the content of various components, means what is the content of, what is the amount of various component in the solution. If we are concerned with their amount of different component, then it comes under quantitative analysis. To determine the amount, here we are concerned with the amount. To determine the amount of various component, in the solution, is termed as quantitative analysis. For example, if we have a solution, it contains how many components? It contains A, B, C, D, 4 components. A is 9 gram, B is 2 gram, C is 5 gram, D is 10 gram. Then in qualitative analysis, we determine that this solution contains 4 components. It means what are the 4 components? A, B, C and D. This A, B, C and D 4 components are determined. This is termed as qualitative analysis. But if we determine that A is 9 gram, then it comes in quantitative analysis. It means what is the quantity of A? That is 9 gram. It's termed as quantitative analysis. Next to that, we will discuss that it is, we know the most of the reactions occur in solution state. Therefore, it is not good to say that this solution is concentrated, this solution is dilute, because we can't differentiate 2 dilute or 2 concentrated solution. So for that, we should express the solution by various ways. We will discuss it. Before that, we will discuss what is concentrated solution. Concentrated solution. A solution which has higher amount of solute is termed as concentrated solution. The next one, dilute solution. A solution which has lower amount of solute is termed as dilute solution. When a reaction is going in solution state, then it is not good to say that a solution is concentrated, a solution is dilute. Therefore, we will express the solution by various ways. What are these various ways? These are W by W, percentage V by V, percentage V by W, parts per million, mole fraction, molarity and molarity. These are the different ways by which we can express the concentration of the solution. Let us discuss them one by one. First, we will discuss the percentage W by W. Percentage W by W, or you can say mass percentage. Mass percentage. Mass percentage. In order to define what is mass percentage means the mass of the solute in the mass of the solute in 100 mass percentage, it is defined as the mass of the component or the mass of the solute divided by total mass of the solution into 100. What we have? Mass percentage W by W is equals to mass of the component by total mass of solution into 100. This is termed as mass percentage. Mass percentage, it means the mass of the component divided by total mass of the solution into 100. Let us understand it by taking one example. If a question is there, the question is there, what we mean by 10% solution of sodium chloride in water. 10% solution of sodium chloride in 10% W by W solution of sodium chloride in water. Then it means that when 10 gram of sodium chloride is dissolved in 90 gram of water, let us note mass percentage is equals to what? If 10 gram of sodium chloride dissolved in 90 gram of water, then what we have the mass of the solution? Mass of the solution is equals to the mass of the solute plus mass of solvent. Mass of solute is 10 gram, mass of the solute is 90 gram, and mass of the component is 10 gram. Mass of the component here 10 gram. Total mass of the solution means solute plus solvent. Here we have mass of solute plus mass of solvent. Mass of solute 10 gram, mass of solvent 90 gram. Then it is termed as